Okay, so this is 2.2 part 2, and we're going to finish 2.2 today. So we're going to pick up at example 3, and some of you may have looked ahead of this already, grade 12s, but let's take a look at this. So example 3, and you see in the picture here that this looks like this might be Serena, and she's measuring off a piece of wood here. So she's using a tape measure, and most tape measures have inches on them. So here's my tape measure. It has inches and centimeters, which I really like these ones, because sometimes the inches, the eighths and sixteenths and all that stuff is a little bit hard to remember for me, and sometimes they're a little bit hard to add. So we need to learn how to add them because it's not intuitive. But the centimeters are very exact, and you can like measure centimeters. 40.2 centimeters is very, very exact, and that's just easier for me to remember. So most tape measures though are in inches. And so they're divided into half inches and quarters and eighths and sixteenths. Some of them 30 seconds, but most of them they kind of end at sixteenths. So we need to learn how to work with those numbers. So Serena's making a new front door for her house. In order to fit properly in the frame, the door width must have a nominal value of 24 inches and a tolerance of 1/8 of an inch. Okay. So we learned yesterday about nominal values. That's like the target value, right? And the tolerance is 1/8 of an inch. Okay. So the range, right? The tolerance is kind of like the range, right? So the minimum value to the maximum value can have a maximum difference of 1/8 of an inch. That's tolerable. Okay, that's the tolerance. So the question says, what are the maximum and minimum allowable values of the door width? Well, if you look at the door width here, let's say this is the edge of the door. So you can have a minimum value of this width and maybe a maximum value of this width. And this has to be 1/8 of an inch. That's it. That whole thing. So if it says what's the maximum and minimum value, well, if we know that this nominal value right here, I think we were given that, right? 24. So that's 24 inches. So it can go half of 1/8 of an inch more, or it can come half of 1/8 of an inch less. So the 24 has got to be right in the middle of that tolerance. And so that's what you do. What you do is you take the tolerance and you multiply it by 1/2. Or you divide it by 2, same thing. And that is sort of the distance or the length above the nominal value that can be the maximum, and below the nominal value that can be the minimum. And that's what they've done here. So the nominal value is 24 plus half of the tolerance gives you 24 and 1/16. And the nominal value minus half of the tolerance gives you 23 and 15/16. So here is 24 inches right here. Whoops, just two of those. 24 inches. And if this is 23 inches, then here is 1/2 an inch. Here is 1/4. This is 3/4 and so on, right? And then half of a quarter is 1/8, 2/8, 3/8, 4/8 is the same as 1/2. This is 5/8, 6/8 is the same as 3/4, and then 7/8. Now if you're taking a 16th away, okay, so look at this. This is 1/16, 2/16, 3/16, 4/16, 5/16, 6, 7, 8, 9, 10/16, 11, 12, 13, 14, 15/16, and then a whole inch would be 16/16. Okay? So if 24, if you add a 1/16 of an inch, that gets you to 24 and 1/16. If you subtract 1/16, now you have 23 and 15/16. That's where you end up. Okay? How many of you have been in construction class before? Okay, talking to the grade 12s. Okay? Construction class? Yes, no? Yes? No? Yes? No? Yes? Yes? Okay. So you've all probably used, maybe with the exception of you, you've all used the tape measure probably with inches on it, right? So you have an idea, right? Okay. So this is very common in carpentry. Okay. Let's move on here. Let's do a build your skills, okay? So the nominal value of a measurement is 16.056 meters with a tolerance of 0.0007. That's 3 zeros and 7. So which of the following measurements meet the standard? Okay. So what you could do right away is you could find out what the maximum and minimum value are. Let's do that. So let's say here's 16.056. That's right in the middle. That's the nominal value, see? And I want to go up to the maximum value. And I want to find out what down here, the minimum value is. Okay? So the tolerance is this number right here. And remember, that number has to be this whole span, 0.0007 meters. Okay? So what we have to do is we have to add 1/2 of the tolerance to get to the max. And over here to the min, we have to take the nominal value and we have to subtract 1/2. Okay? So I want you guys now to take a minute and tell me what the minimum value is and what the maximum value is. So go ahead and get on your calculator there and see if you can do that. So take a half a minute to do that. Okay, so hopefully you had a chance to do that with your calculator. I did it on my calculator over here, and let's see if I typed everything in right. So 16.056, okay, that was my nominal value, and I want to add half, so I did 0.5 times the tolerance there. So when I added half the tolerance, I got 16.05635. Anybody else get that?
Why would you add half?
Why would you add half? Okay. Well, let's look at this diagram over here. So remember, from the maximum to the minimum has to be a total of this tolerance right here. So if you start in the middle, to get to the maximum value, you have to add half of the tolerance. Okay? So we're not adding the whole tolerance, we're adding half of the tolerance. Okay? All right? So that's again, this is the maximum, and then if you subtract half of the tolerance, that's the minimum value. So if we subtracted these two numbers, let me do that, so the largest one is 0.5635, and we subtracted the smallest one, 16.05565, that should be the tolerance. Now 7 times 10 to the negative 4 is just scientific notation, and that means we have a 7 and the decimal place is moved back 4 times. And that would be the same as this number, 1, 2, 3, 4. So that's the same. Okay, that's just step 1 there, okay? Step 1. So what we have to do now is check to see if each of these numbers are inside of this range or not. Okay? So there's 2 different ways you can do it. The first way, what I'm suggesting, is find the minimum, find the maximum, and then see if these numbers are in between. So we have 16.05635 and 0.5565. So where's this one? 5672. 5672. That looks like it's above this value, doesn't it? 0.5672. So is this acceptable? Looks like not. No. Because it's above the maximum allowable. What about this one? 55757. So 55, oh, there's a 6. Oh yeah, this one is going to be inside here somewhere. 55, and then it's just above this 6. It's 7. So that's a yes. Now, here's another way you could do this. This isn't, if you don't like this way so far, if you're like, I can't tell, Mr. Maxwell, if this number is in between those or not. Okay, let's do this then. Here's method number 2. What you do is you take each value that you see, like this one right here, 16.05605, and you're going to subtract the nominal value. So you're going to find out how far it is away from this nominal value. So 16.056. And we're going to find out what that is. Okay. Then you're going to ask yourself, is that difference smaller than half of the tolerance? If that difference is smaller than half of the tolerance, then you know it's inside the middle to the maximum, or inside the middle to the minimum. And so 5 times 10 to the negative 5 actually looks like this. 1, 2, 3, 4, 5. Like that. The 5 there. So that's 5 times 10 to the negative 5. So is that smaller than this one? Half the tolerance is 0.0035. That's half of the tolerance. So this is much smaller, isn't it, than this? Okay? Much smaller. So that's another way you could do it. And you say, yes, that's within. 5605, 56, see it's just underneath this one? So that's a yes. Okay? So I'm going to leave the rest blank for you to do in a few minutes, but let me just go over just number 6 a little bit. Okay? I spent a lot of time on number 5 there, so hopefully you're good with that. Number 6 now says this: write the maximum and minimum values represented by each of the following dimensions. So this one says 350 Fahrenheit plus or minus 5 degrees Fahrenheit. This is pretty easy, right? The max is going to be 350 plus 5, or 355 degrees Fahrenheit. That's the max. And the minimum is going to be equal to 350 minus 5, or 345 degrees Fahrenheit. Okay, so that's pretty easy. But what I'd like to skip down and do here is like something looks like this, because this looks a little funny. We haven't spent a lot of time on this, so let's just talk about this again. Okay? So this looks like a mess, doesn't it? That looks really weird. The same as this one over here, I think is, yeah, that one's a mess too. So let's think about what happens here. So this is saying that this value right here plus 0 is going to be the maximum value. And this value minus this is going to be the minimum value. That's what that means. So I'm zoomed in, so let me get a smaller size pen here. Okay. So the max is going to be 3 1/2 plus 0. Well, that's 3 1/2 inches, isn't it? That's the max. The minimum is going to be 3 1/2 inches minus 1/8 of an inch. Okay, so here's where we have to remember what we did yesterday. Right? Oops. Change my pen size again. And we have to actually subtract these. So we need to get a common denominator. So 3 times 2, 2 times 3 plus 1 is 7 over 2. That's what that fraction is actually like. And minus 1/8. So switching from mixed to improper fraction, that's step 1. Now we need a common denominator, right? So in order for 2 to be like 8, all I have to do is multiply by 4, and then that becomes the same as 8. And what I do to the bottom, I have to do to the top. So this becomes 7 times 4 is 28 over 2 times 4 over 8 minus 1 over 8. Now this is easy. We just subtract the top numbers and we get 27 over 8. Okay? And that's going to be inches, I guess. And that's going to be your minimum value. Okay. So for questions, for build your skills number 5 and 6, do you guys have any other questions before we kind of move on from there? Okay. So, and there's number 7 as well, so I'll get you to do number 7. So I tell you what, let's take a look at example 4 and do the last little bit of this lesson, and then I'll let you go back and finish all the questions. Okay? All right, so let's focus on number 4, the last example before we're pretty much done this section. So, example 4. Christian is building a brick wall as a fence in his client's yard. His clients have asked that the wall be 2.4 meters tall with a tolerance of 10 centimeters. Okay? So you can have a range of heights there that span 10 centimeters only, so as not to obstruct the view from their patio and so that their dog will not be able to jump over the fence. So there's a maximum. They want to be able to see over this maximum part, and the dog can almost jump that, so they have to be higher than the minimum so the dog doesn't jump over. What is the range of acceptable heights of the wall? Okay, so they're asking you for what is the maximum and the minimum. Well, this shouldn't be too hard, really, should it? We've got 2.4 meters is the target, and I need to find out what's the maximum it could be or the minimum it could be. So this one is plus 1/2 of the tolerance. So plus 1/2 of 10, and this would be minus 1/2 of 10. So if you have a number that's in the middle of the range, you add half of the total range, and then you subtract half of the total range to get the maximum and minimum. Good? So let's see, that would be 2.4 meters. Now this is 10 centimeters, so I guess we got to be careful there, don't we? Okay, so that's actually 0.10 meters. Well, we have to watch our units, don't we? That's 0.10 meters. So it could be 2.45 meters, or it could be 2.35 meters, I think. Okay, so 2.45 meters is 245 centimeters, and this is 235 or 2.35 meters. So that's A. This is in a real life situation, so it's good for us to do that. Now B, let's see, if each brick has a height of 7.5 centimeters plus or minus 0.25 centimeters, and the mortar must be between 0.75 and 1 centimeter thick between each row of bricks, how many rows of bricks and mortar will it take to build the wall? Wow. So that's a multi-level question there, isn't it? We have bricks and we have mortar. You're going to start with the brick, you're going to put some mortar. You're going to have another brick, you're going to put some more layer of mortar. Brick, mortar, brick, mortar, brick, mortar. So you have to figure out how many bricks would fit that would land somewhere in that range. Okay? So you could do this a number of different ways. You could just draw it out. You could make a sketch and do it that way. Here's their solution. So the maximum height of each brick they found out, and here's the minimum height of each brick. Here's the maximum combined heights of the mortar and the brick, and the minimum combined heights of the mortar and the brick. And then they figured out, hey, how many groups of this fit into our upper range, and how many groups of the smallest possible combination could fit into the range. So yeah, you can read through this in a little more detail if you want, but they basically, see here they go, 235, that's the lowest, divided by the maximum, and they get 26.9, and so on. So you could have anywhere between 26 and 30 or 27 and 30 layers. Okay, that's what they came up with. So that one will require just a little bit more kind of thought, right? But that's, anyways, if you want to read through this solution, it's right here. And I think you guys maybe are ready for a question like that. So let's do one of these questions here together, and then I'll set you off for the rest of the class on your assignments. So number 8 says an electrical resistor has a resistance with a nominal value of 100 ohms and a tolerance of 3%. Oh, this is a bit different. Okay. So 3%. How do you find percentage of something? What do? You multiply, okay? You multiply by what? How do I find out what 3% of 100 is? I do 100 times what? 3? Well, it's not times 3, it's times 3%. So that's actually 3 out of 100. Right? Or you multiply by the decimal form of the percent. Remember that? You want to find 3% of something? Multiply by the decimal form of the percent. So what's that going to be? That's going to be equal to 3. Okay? So 3% is the tolerance. It can have a range of a total of 3% there. So what's the range of acceptable values in ohms? Well, it would be 100 is the target plus 1/2 of the tolerance. That's the max. The minimum is 100 minus 1/2 of the tolerance. So this is going to be 101.5. And this one is going to be 98.5. And that would be ohms. Okay, so the range is going to be the difference between these two, I guess, right? What is the range of acceptable values in ohms for the resistor? So I guess anywhere from 98.5 to 101.5. Okay, so I think I got that right. Okay. All right, so that's the examples I'm going to do with you. These are the questions I'm going to do with you. What I would like you to do now is to complete all of the build your skills up to number 10. Okay, so do 1 to 10 for 2.2. And then I want you to do the practice your new skills. So this is the summary of this section. The practice your new skills. You do have lots of time here to work on that. Okay. And then that brings us to the end of the chapter, right? Brings us to the end of the chapter. So, for tomorrow, this is what I want you to do today. Finish your build your skills questions, all of them up to 1 to 10. Then practice your new skills, okay? And tomorrow you should have all that done. I'll probably give you some time to work on that tomorrow, but we'll see how well you work today.